Relativity is the study of how different observers measure the same event. While the idea had been studied for centuries before him, the modern theory of relativity was developed by Albert Einstein. The ideas are most closely associated with Einstein because he was able to use the ideas within relativity to make predictions about time and space that have since been verified. Relativity is divided into two parts. Special relativity covers observers who are moving at a constant velocity, while general relativity deals with observers who are accelerating. In the late 1800s, two physicists, Michelson and Morley, managed to directly measure the speed of light in an experiment known as the null result. Interestingly, this velocity was independent of any type of inertial reference. This means that anyone who observes light in a vacuum will see it moving at the same speed, no matter how they might be moving relative to the source of the light. According to Newton's laws, two observers moving at different speeds should see the light traveling at different speeds. So the results of this experiment came with a pretty big question of why the velocity of light remains unchanged when looked at from different reference frames. The challenge then was to reconcile Maxwell's electromagnetic equations with Newton's laws. In 1905, Einstein conducted a series of thought experiments that really became the basis for his theories of relativity. One of his thoughts was that what would happen if you were actually riding a beam of light. Basically, if you were moving along a beam of light, you would see alternating electric fields and magnetic fields that would be at rest with respect to time. So the electric and magnetic fields would increase and decrease with respect to space as you moved along the beam of light. However, the fields would remain stationary with respect to time. So since these fields do not actually obey Maxwell's laws for electromagnetism, it is impossible to reduce the relative speed of light at all. Einstein's theory of special relativity is based on two postulates. First, all laws of physics hold up in all inertial reference frames. This includes Newton's laws of motion, the law of universal gravitation, and Maxwell's equations for electromagnetism. When we say inertial reference frames, what we are talking about are the things that are stationary or moving at a constant velocity. The idea of inertial reference frames is really the cornerstone that holds up the entire idea of special relativity. Einstein's second postulate states that light can move through space and does not need a medium to do it. This velocity is constant and does not depend on the source of light or the speed of the observer. So the speed of light is constant and independent of the speed of the observer and the source of light. So no matter where that light comes from, or where you are, or how you are moving, the speed of light is constant. These two postulates served as the basis for special relativity. Everything that we look at from here on out with regards to special relativity assumes that these two things are true.